Day 145, Honors Physics, applying Kirchoff's laws. This is problem number 40. The general idea, there's two laws. The general idea is to first start with the first law, the current junction law, and that is, if you look at this diagram here, there are two junctions. There's a junction right here, and that red dot I just highlighted at the top. And down here below the 4 ohm resistor, there are two junctions. I'm going to call those points A and B for now. Those are the only junctions here. There are 3 branches, in other words, 3 connections between those 2 points. One current in that middle branch is already assigned. I'll use blue. But I know that this is 2 amps right here in that branch. Current from A to B is 2 amps. So what you want to do then is assign all the branch currents. We only know one of them right now, but there's also current. Now, there's some special symbols here. This E right here stands for electromotive force, EMF. It says it up here in a problem, EMF. That stands for voltage. It's a fancy way of saying voltage. So when you see that, that means voltage, V. So we're looking for the voltage of this battery over here, the EMF. I guess old school is called electromotive force. The force, in a sense, that's pushing the current, the energy that gets the current moving. Now, the battery over here on the left, once again, the long side is the positive side. In other words, this battery has its positive side up here and negative side down here. I'm looking at this battery on the left-hand side, the unknown battery, and it's pushing current up and clockwise. So I'm going to indicate that from point B to point A. So this blue arrow I'm drawing in a diagram right now represents current in that branch alone going from point B to point A, because that battery is pushing in that direction. Now, if the other battery is much, much stronger, the current may not go in that direction. So we're taking our best guess right now on that current. As you solve this problem, if that current comes out negative, then we know the current's in the other direction. Now I can use, well, let's just symbolize that as I sub 2. I sub 1 is already known as 2 amps. Okay, on the right-hand side here, this 12-volt battery way over here on the right-hand side, that's pushing current up, or in other words, from that branch from B to A. The current is likely going this way, unless the other battery is like 100 volts or something like that. That current could be the other direction. I doubt it is, but we'll find out. I'm going to call that I sub 3. So bottom line is you want to start typically with the first law, looking at your junctions A and B and assigning the branch currents for each branch that joins the junctions. In this case, we have 3 loops, the 2 small loops and the outer loop, which we'll talk about as we go along here. Okay, so now here's some easy pickings right now. We only know one current, so we can't do much with the first law other than so far just assigning those 3 currents. But the middle branch from A to B, I know I have 2 amps. It's a 4 ohm resistor, so right away, using Ohm's law, which is, your V equals IR, you can do this in your head. I'll just jot it down, V equals IR. I know that the current is 2 and the resistance is 4, so I already know that the voltage for that resistor in the center there is 2 times 4 is 8 volts. So I can jot that down. This resistor, I'm going right above the 4 here, that's 8 volts. I don't need to show work for that. I can write it on a diagram. So a lot of these, you write them on a diagram. You don't need extra diagrams, but show a little bit of work. We'll show some work here as we go along, but the arrows are a part of the work, showing those 3 arrows that I have drawn, one of which was given, showing the branch currents. Okay, so now the second law, the sum of the voltage gains and losses, rises and drops, is 0. The energy input equals the energy output. The total amount of energy in any loop is 0. Potential difference, more specifically, but that's related to energy. So what I do is you pick any loop, but I try to pick an easy loop. And the easier loop here in this case, because I've done enough of these, is this loop right here. If I go around this direction, and I probably should label a few more points here just so I can do this a little bit better. So if I go, I call this point C, and let me use red. Point C on the lower left corner, point C lower left, and point D up here, upper left. So if I go back now, and you can start anywhere you want. Start at point A or B or C, doesn't really matter, but I'm going to go around this loop right here. So now I'm going to go around this loop, so I'm going to follow this path. All right, the nice thing is my currents that I've assigned are in those directions, so everything will be conventional as far as positive and negative that I've outlined in previous notes. So this is the loop I'm going to take. In this loop, from A to B to C to D, there are 3 elements. So if I look at loop A, B, C, D, and back to A, there are 3 elements. So generically, I'm going to have V1 plus V2. I'll have 3 voltages that add up to 0. V2 plus V3 equals 0. All right, so I'm already seeing that that was the more difficult loop to pick. So I'm going to hold that thought for a second. Let's go back over and look at this other loop. If I go this loop, this is actually going to, you'll find out this is the easier loop. Sorry about that. Doesn't matter, but this is, you're going to find out here as I do this. In this loop right here, if I go around this way, counterclockwise, I'm going with those blue arrows. That's always nice. When you can find a loop where you're going with all the assigned arrows, everything will be conventional in your loop application of the voltages. So once again, in loop, and I'll name these E and F, those 2 corner points, points E and F, just for reference. So now I'm going to do, instead of loop A, B, C, D, I'm going to do loop A, B, E, F, A. A, B, E, F, A. Okay, so let me pause. All right, so once again, in that loop, there are 3 voltages. So just, I'm stating this generically right now. V sub 1 plus V sub 2 plus V sub 3 equals 0. But if I start at point A, going back to the diagram, and go from A to B, the first element I come to is that 4 ohm resistor, and I'm going with the blue arrow, the 2 amp current arrow, so that's conventional negative 8 volts. So that will be negative 8 volts. I'm leaving the units off for now because it's all volts. Plus, or well, maybe it's minus, let's see. Look at the diagram. If I'm going from B to E to F, the next thing I see is the 12-volt battery. And I notice that I'm going with the direction of the battery. In other words, with the battery, the bottom short terminal is negative and the top terminal is positive, and that battery is pushing up, and I'm going with the push of the battery, so that's the conventional plus 12. So that's plus 12. And then that last resistor, which I don't know the voltage for yet, minus, I'm going to call that V sub 8, the 8 referring to 8 ohm resistor. You could have left it as V sub 3, but I'm referring to that top 8 ohm resistor here equals 0. Well, you can see there's one unknown in that equation over there. Bottom line, simply put, V sub 8 comes out to be 4 volts. The voltage of that resistor at the top is 4 volts. That's going to be very critical in solving this problem. Actually, the pieces fall right into place now. It's an important number. It's not the answer. But if I go back up to the diagram and label that resistor as 4 volts, and I know its resistance is 8 ohms, using Ohm's law, V equals IR, applied to that 8 ohm resistor, it's a 4 volt resistor with an unknown current, that's I sub 3, times the resistance of 8 ohms. You could have done that in your head. I sub 3 is indeed 0.5 amps. That's huge because once I know that I sub 3 is 0.5 amps, now what you do, you can go back to law number 1 now. I always go back to law number 1 as quick as I can if it's helpful. In this case, it is very helpful. So now if I'm looking at point A up here, I know I have 2 amps coming down, and I have this current in this branch, I sub 3, is 0.5 amps. So far I have 0.5 amps going into point A. Well, the rule in rule 1 is all the current going in has to equal the current coming out. So I have 2 amps coming out, only 0.5 coming in, so I already know that I sub 2 must be 1.5 amps. That's how I deduce that I sub 2 right away now is 1.5 amps. And once I have that, I can go back to my original loop that I was going to apply the loop rule to, this loop over here where I was going to go from A to B to C to D to A, and add up my 3 voltages. Oh, because I know, let's do one more sub-calculation first. I know that the current in that 10 ohm resistor now is 1.5 amps. So I have 1.5 amps. The I sub 2 is 1.5 amps. I'm looking right by the 10 ohm resistor right now. So if the current in a 10 ohm resistor is 1.5 amps and the resistance is 10 ohms, V equals IR dictates that the voltage of that resistor is 15 volts. So I'm going to write that down in the diagram, 15 volts for that resistor. which now leaves me only one unknown voltage in that loop, A, B, C, D, A. So, once again, those of you who are thinking ahead can see this now right away, but I'll write it down. Going back over here now, where I have my loop calculation to show work, I'm going to plug in. As I go from A to B, I have my negative 8 volts for the resistor, the 4 ohm resistor, plus my unknown V sub 2, which is my battery that I'm looking for, that script E, EMF, and then minus 15 equals 0, because once again it's a minus 15 since I'm going with the flow of the blue arrow. So the batteries you do by the path you're taking, the loop you're taking, the resistors you do by whether you're lining up with your current assignments. All right? So the batteries are irregardless of the current flow. They're based on how you picked your loops. You'll see more of that as we go along here. But bottom line is now, if you look at the math over here in the middle, V sub 2 has to be 23 volts, and that's what we were looking for. It's the stronger of the two batteries, and that's the final answer.